Hey guys, if you just tuned in there and watched the first video and the second video about EPP for electrical engineering level 2, I was interrupted by a call, guys. The reason why the videos are split, they've been being disturbed by a call there, right? So I'm sorry for that. So let's proceed there. So guys, I even made a mistake here. I meant to say 10 to the power 6. Né? If you can check my previous video there, I made a mistake. It's supposed to be 10 to the power 6 because it said must multiply by a million. So if you want to say million, you can just simply say 10 to the power 6. Then we'll give you this, right? Then therefore let's proceed here. So it's been the mass is being given by it's 500 grams. So remember, whenever you're doing the force calculating this, the mass must be in kilograms, not grams, guys. Don't forget, ne? When you've been given a mass, must be in kilograms, not grams. So let's ask ourselves there. So in one kilogram is equals to 1,000 gram there, right? So this is formula works like this. So if you want to convert kilo to gram there, right? So you multiply by 1,000 there. Then if you want to take a gram to a kilogram, you divide by 1,000. That's vice versa. So same thing applies here. So it means you're gonna have what? So basically it means 500 gram you are divided by 1,000 there, right? So it's gonna give us 0. They give you a mark there. I'm sorry, my show calculation there. So I can just simply show it here. So I can just write 500 divided by 1,000, right? Times acceleration is 5. Oh, sorry, I just didn't write 5 there. It's 5 there, right? Then therefore, oh, you must show the SI units there. So it's kg, ne? So it's gonna be kg because we're multiplied by 1,000 there. Then here it's meters per second squared. Then we're gonna have our final answer there. We're gonna have the second step. We're gonna have this. So when punch it, it's 0.3, right? Kg multiplied by 5 meters per second squared. Then we're gonna have 1.5 kg meters per second squared. Meters second squared, né? Right? Then meters kg kilogram meters per second squared, it's Newton. So the final answer will be 1.5 Newton. So force is equals to 1.5 Newton there, right? So this is how you do number 1. So you are done doing number 1.3 there. You are done doing this question here. 1.3, right? I hope you understand that. Please share the video, or if you want more clarity in your home language, guys. Ke bolela Sotho, ke bolela Zulu, bit of Zulu, Xhosa, re ka zama le mo, ne? And then then I will help you there if you want it in your own language. So this is, I'm a tutor from Mamelodi, Pitori, so I can also speak Pitori there. So if you are around Pitori and Gauteng, you know the languages go hand in hand. So go to select scars if you understand, right? So but for now, since it's universal language English, so I must do it in English. You never know. So you'll find that there's a foreign one do not understand this, so you want clarity on that. So please, if you want more clarity or more extra attention, just take my number on my bio, then we'll talk about how do we go forward about this, right? So we have done question 1. There it is there. right? So you're done. Question 1. Okay, people, let's proceed with question number 2. So question number 2 is there states an electric kettle with a power rating of 1.5 kilowatt is connected across a 200 volts supply. Calculate the following. The 2.1.1, it says the current drawn by the kettle from the supply there, right? So we're calculating that there, right? So firstly, there you look at the question there, right? The statement that is being given there. So we've been given what? So there you're saying we have the power rating there. If you read the statement, the scenario there, we've been given the power rating there. Right? So my power it's kilowatt. So first thing that we do, we analyze what we've been given. So it's number 2. So P is equals to 1.5 kilowatt, right? And then what else I've been given there? So I've been given also volts. Volts, it's 2000 volts, right? Voltage, right? So I've been given those 2 information there, right? So they are looking for what? So analyzing what we've been given, as I used to usually tell you guys, you analyze what we've been given there. So we've been given power and voltage there. Then we check there. The question there says calculate the following: the current drawn by the kettle from the supply. So I'm looking for the current now. So it means current. Remember, it's I. So I is unknown. Right, so I've been given P, given V, been given I. Oh no, I mean to say we are looking for an I, right? So I've been given power, voltage. I'm looking for current. So, guys, as I was saying, why I'm stating this, or why I'm doing this style, is because I'm making life more easier. Like we find sometimes, guys, like not necessarily these things are difficult for you. You guys, the reason why some of you fail this is because sometimes you don't understand English on its own, right? Or the question when how is it asked? It might be bombastic for you, or it might be Chinese to you, or foreign language for you, or the English might not be coming right for you to understand it. So that's why I'm doing this. Why I've been doing this again is because you check. Okay, I've been given P, been given V. They're looking for I. Then you go to the formula sheet there. You know, check the formula that consists of those 3. Then you go to the formula sheet there, right? So you go to the formula sheet there, you look for this kind of equation there. Here's the formula sheet. So if you can check, here's it. P equals to V times I. Then you write it down. So I have P equals to V times I, right? Oh, this is 2.1.1 there, right? So here's it there. So it's a matter of now they're looking for I. So you can do it this way. So you can make I subject of the formula there. So let's make I subject of the formula there. So we're gonna have P is equals to V multiplied by I. Then I make I subject of the formula, so I divide by V both sides. So this will cancel this. Then I will equals to P over V, right? Then therefore I will equals to, remember I've been given my power there, it's 1.5. But if you can check that, they said it's kilowatts. So SI unit for power, it's watts. So that's a kilo. Then you must check kilo, guys. It's from the prefix there. It's one of the prefix. So check the prefix symbol there on the table that I showed you guys. remember that table that I showed you there of prefixes, mega, kilo, you know, k, what, the prefix there. You go to the table and check. So if you can check there, it will tell you the table there. Kilo, you must multiply by 10 to the power 3, means you must multiply by 1,000, right? Then therefore we're gonna have over volts it's volts. The voltage is being given in volts, so it's 220 there, right? Then therefore the final answer will be what? Therefore I will equals to 6,82. If they say into 2 decimal places, in most cases they say 2 ampere, so it's 6.82 ampere. In most cases they will say correct to 2 decimal places there, right? So this is how you find I there, right? So I hope you understand, guys. If you want more clarity, you can take my number on my bio, check there, and then I'll clarify this answer to you in the language that I've just mentioned earlier on there, right? Which is Spady, Sotho, Spady, Zulu, and a bit of Xhosa there, but bit of Xhosa in it's like Spady and Setswana, they go hand in hand. Some words are similar, then also Xhosa and Zulu, they're similar. So I know that Xhosa people last ukuthetha is Zulu, so ngaze acacisela ukuthi size kanjani, right? So yeah, but with Spady and Setswana I'm fluent there because I'm Pedi. So yeah, guys, I hope you understand there, right? But if you are a white person, we'll just keep on doing your mother language, which is English, and explain there, right? So that's number 2.2. It's 2. Let me just check there. It's 2.1.1, right? So let's proceed there. So now let's go to 2.1.2. Right, so there we go to 2.1.2 there. So they say the question says calculate the resistance of the kettle element. So we're looking for what? We're looking for a kettle element there. So key resistance is unknown of the kettle element. So we go to your formula sheet. So now remember, you have your power, you have your voltage, you have your current. You don't know, you're looking for this. Then you go to the formula sheet there. Let me go to the formula sheet there. You check the one with that thing there, right? So if I can check on my formula there, I have a formula that consists of resistance there, which is this one. Why am I choosing this formula there? It's because if you can check, I have voltage is been given. I just recently found I, right? Then I'm looking for resistance there, right? So I can use that formula there, right? So guys, another thing that you should know is that with this, especially with physics or science on itself, I've noticed with physical sciences, the questions before, like the question that you did before the current one that you're doing, you found that it might help with the question that you are doing now. Meaning that sometimes I'm saying that the previous question that, let's just say you are on 2.2, 2.1 can help you to find the answer of 2.2. Are we together, people? So this is how they work, ne? So you must take note of that. You see it here, this question. To find the resistance of the kettle, I said that I showed you in the formula sheet. I can use this question. So it's 2.1.2. This formula of V is equals to I times the resistance there. So it's voltage equals to current times the resistance. So why I chose this formula is because I've just found I have voltage has been given. This one I just recently found it. So you see, and this one we got it from the previous question from 2.1.1. Yeah, they're looking for this. So must take that in note, né? So let's proceed there. So basically, what do we have there? So like we can also make the subject of the formula. We can just make r subject of the formula. So I divide by I, this cancel this, then r equals to v over I, right? The resistance will equals to 220 over, what's my current there? So I got my current as 6,82, right? So here it's volts, here it's ampere, then therefore resistance will cost to 32,260. Remember the SI units for resistance is ohm, right? So that's 2.1.2. So let's go to 2.1.3, right? So 2.1.3 there it says the energy consumed by the kettle after an hour. Yo guys, my battery is dying there. And I also time is being my battery is about to die. I have a battery, but I still have another lesson for some of my students there. So I'll also go live, maybe doing another questions there. But if you want more help with this, you can just take my number on my bio, and also yeah, I can say that. So this is I'll be doing this last question here, and then we will see some other day there. So now we are looking for the energy consumed by the kettle after an hour. Write your answer in megajoules. We are doing this question there. Energy consumed by the kettle after an hour. Write the answer in megajoules there. Right. So we check there. Right. So basically, energy. The formula for energy there. Remember, let's talk about energy, guys. What is energy there? Let me just quickly define energy there. Right. Let me quickly define energy there. Let's quickly define energy. So energy is the capability of, or the capacity of doing work. That's energy there, right? So we check there. Right, let's continue looking for energy. The question says calculate the energy consumed by the kettle after an hour. Write your answer in megajoules. So we have, if you can check formula there for energy, we go to it. If you can go to the formula sheet, right? So due to I want to finish this question, my battery is about to, I want my phone to charge. So it's E energy is equals to P times T there, right? So T there stands for time, or capital letter T. I meant to make T capital letter T there. Then therefore we have our power there. So our power, we got it as what? So our power there, we got it as 1,5 times 10 to the power 3. Remember, it's kilowatt, right? So you must multiply by 10 to the power 3. Then times, what is my time? They say after an hour, so it must be in seconds. So how many seconds, how many minutes are in 1 hour? It's 60. Then how many seconds are in a minute? This is another 60. So it's 60 times 60. So whenever convert 1 hour to seconds, it's 60 times 60, right? Then this one will give me, this one when I punch it will give me 1,500 times this one will give me 30,600. Then when I multiply this, they will give me 5,400,000 00000, right? Joules, right? So they remember they said that they wanted in the answer in megajoules. So I must multiply this 5,400,000 times 10 to the power 6 is mega, right? Then we have 5.4 megajoule there. Then you are done. You got your energy there. The energy consumed by the kettle after an hour, right? So guys, if you want more, you can just simply take my number display, right? So thank you for watching the video so far. Please comment. Any comments, they are welcome in the languages that I just mentioned there. Spedi. If you don't want to comment in English, you can comment in Spedi, Zulu, Xhosa, or find someone to translate for me. But yeah, thanks for tuning in. Please love the video there and share. And if you want me to help you with EPP, you can take my number on chat. You can call or chat on WhatsApp. Thanks, guys.